Boom. 1 cubic inch.
Cubic centimeter.
Cubic centimeter. All right. You gotta get neat. Stand over there.
Cool.
Volume. Volume is how many square units, cubic units can fit inside of an object. Okay, so we've got this. This is 1 cubic inch. So it's 1 inch by 1 inch by 1 inch. So this is 1 cubic inch, and this is 1 cubic centimeter, 1 cubic. So the question is, how many of these, you ready? How many of these little things do you think could fit inside of this? And I could shave off the corners, but if I stacked a whole bunch of these in here, how many of these little cubic centimeters do you think could fit inside of this? Okay, so just keep it inside your head. Okay. Now, there's an equation for this that we can use to calculate the volume of a cylinder. And a cylinder is pi r squared h. That's the equation to find the volume of a cylinder. So what we need is the height of it in centimeters. What is that, about 18? 18?
About 15.
15? Am I messing it up?
Yeah, because you're tilting it.
15, okay, so the height is 15. Okay, and then the radius, well, this is the diameter is all the way across. The radius, so the diameter is 10, so my radius is 5. So the diameter is 10, the radius is 5. And for pi, we're going to use 3.14. So that's what we're going to be going with. We got a height, a radius, and pi. Okay, I'm going to multiply that together. And we're going to get 15 times 5 times 3.14, 235. You know what? I didn't square it. Let me try this again. 15 times 5 times 5 times 3.14. 11775. Okay, so that's what we think. So we're going to measure this now. We think that 1,177.5 of these will fit. Now, we're not going to be that accurate, but let's see how close we get. Here we go. Hopefully I have enough water. Did I make enough water? Enough blue water? I did. Okay. Now here's the deal.
It looks like orange nuts.
In the metric system, 1 liter is 1,000 of these. So 1 liter is 1,000 of these.
So it's a little more than a liter.
So a little bit more than a liter. So let's see. Here we go. This should be a little bit more than a liter. Okay. I'm trying to be level.
No.
Not quite a liter yet. Okay, so that's 1,000 so far. So we've got 1,000 little squares. That's 1,000 little squares right there. And then we have a little bit more. 1,000. And then what is that? That's about 1,000 and a little less than 200. So we're a little bit less than 1,200. We're a little bit less than 1,200. So it's accurate. This equation really did work. Now, we're also going to try a cone. So here's a cone. Now, it's not a perfect cone because it's got this extra piece down here, and I don't know how to plug it up. But we're gonna see if we can get close to the cone. Now, the equation for a cone, ready? It's just like the equation for the cylinder, except you divide the answer by 3. So a cone is going to be pi r squared height divided by 3. So that's it's a cylinder divided by 3. So whatever that is, we just divide it by 3. Okay, so let's find our measurements for this. And it's not going to be perfect, but we'll see if we get close. Let's start with the diameter is about, let's go with 15. So what's half of 15?
30.
Half of 15.
5.5? No.
Nope.
5.5.
What's half of 14?
7.5.
7.5. Okay, so our radius is 7.5. And our height that we're going to use is just this piece right here, and we're going to call that at about, it's an estimate, we're going to go with 9. Our height is 9. So we're going to go 7.5 times 7.5 times 9 times 3.14 divided by 3 gives us 530 about. All right. 530. Let's see how close we get. This is going to be tough because I have to kind of plug it up.
Why don't you try to? Why don't you go for it?
All right.
Blue juice.
All right, I filled it up.
Blue juice.
Now this is going to be a little bit high because it's got this volume down there at the bottom, but we'll give it a shot. See how close we get. I said 530. How close are we?
450.
450? Okay, you know what? It's good enough. All right, there we go. That's volume. Hey, this is Mr. Barre, and these are the notes that go with volume of spheres, cylinders, cones, and hemispheres. So the first thing I want on your notes is your name. So put your name big up at the top. And our title is volume of cones, cylinders, spheres, and hemispheres. So volume of cones, cylinders, spheres, and hemispheres. Everything starts with a circle. All of these guys start with a circle. So a cylinder it starts with a circle that then gets extended down or up to create a cylinder. So everything starts with a circle. So there's a circle with a radius, and I have a height. So to find the volume of the cylinder, I'm first going to find the area of the circle, which is pi r squared. That's the area of the circle, and then that thing pops up into the cylinder times h. That's the volume of a cylinder. It starts with the area of the circle, and then it pops up to create the cylinder. So that's your volume for your cylinder. Now imagine I take that cylinder and I shave off the sides of it and I turn it into a cone. So can you see how there's actually a cone inside of that cylinder? Well, a cone once again, it starts with a circle with a radius of r. So I have pi r squared. It pops up with a height. So pi r squared h. But it's not the full cylinder. It's actually lost a lot of its volume. So I divide it by 3. So it's the area of the circle, which is pi r squared, times the height. That gives you the volume of your cone. Our next one is the sphere. Now the sphere is weird because it doesn't have a height necessarily. What it really has is I don't even know if that looks like a sphere anymore. Okay, but it has a radius, but that radius is actually going off in all directions, isn't it? So the radius actually is going to be used as the height. So what we're going to start with here is the circle again, which is pi r squared. Now, normally we would have a height, but we don't have a height. What we have is another radius, the vertical radius. So I'm going to use another radius here. So I actually now have pi r cubed. Right? So it's like the cone, pi r squared, but I don't have a height. Oh, there's the cone. Pi r squared h, but instead of an h, I have another r. So pi r squared r divided by 3. It's like it's the cone, but times 4. This is actually 4 pi r cubed divided by 3. 4 pi r cubed divided by 3. And that's your volume of your sphere. 4 pi r to the third divided by 3. And our final one is the hemisphere, which is just half of a sphere. So a hemisphere, this was sphere, wasn't it? Hemisphere is just the sphere divided by 2. I'm not going to give you a second equation for that. You just find the volume of the sphere and you divide it by 2. Right, what we're going to do now is some checking for understanding. I'll do a couple of problems and you can see if you get them right. If you want to pause the video if you're watching this later. Alright. So I am telling you, I'm going to give you a cylinder. Here's the cylinder. It's got a height of 4 and it has a radius of 3. We're going to use 3.14 for pi. Round it to the nearest tenth. What do you get? I should get a calculator so I can do this also. Oh my goodness. I don't have a calculator. Do I have a calculator over there? I don't want to. Can I pause this? I can't pause it. Okay. Round it to the 10th. Let me see if I got my calculator over here. I don't. Hey look, they're the little cubes from my other video. I'll pull the calculator. Alright, so what do we have? H times H, no, yeah. 4 times 4 times 3 times 3.14. So 4 times 4 times 3 times 3.14. I'm getting 150.72, which would round to 150.7. Let's do a cone. Ooh, I'm going to mess with you though, okay? So I have a cone. But I'm not going to give you the radius. I'm giving you the diameter. The diameter equals 12. And the height equals 20. Diameter is 12 and height is 20. Give go and do that. And I'll try to do it also. Let me get my mouse. There we go. That's better. Diameter is 12. I have it as 753.6. 753.6. Hopefully I got that right. And now let's do a sphere. I'm going to use the same piece of paper. A sphere with a radius of 10. A sphere with a radius of 10. What is the volume of that? A sphere with a radius of 10. A radius of 10. Got it. Okay. Oh, okay. I have it as 4,186.66666, so that would round to a 0.7. All right. Thanks for watching. I'll see you later.